You guys have seen scientific notation before. Some of this is review, but I'll teach it again as if you haven't seen it. Some of it is new, operations with scientific notation. So, does anybody know why this is called scientific notation?
It's a big one.
Okay, in science, sometimes you have really giant numbers, like how far is it from here to Mars, or how many cells are in your body, or sometimes you have really tiny numbers. Shh. Sometimes you have really tiny numbers, like what's the width of a cell. So instead of writing gigantic numbers that don't fit on a page, you can use scientific notation. So it's a way of writing them smaller. Okay, so how this works is you always put the decimal after the first digit. So this would become 3.457. But obviously these two things are not equal. So how do I make them equal? You always do times 10. Basically every time you multiply by a 10, it moves the decimal one place. So how many 10s do I have to multiply by to get the decimal? Now normally the decimal is like at the end of the whole number, right? So how many decimal places? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. Or if you can count by threes, 3, 6, 9. Anyway, those two values are equal. It's just a much smaller way of writing the same thing. If you, on your calculator, if you plug in like something times something is too big, it'll give the answer in scientific notation.
What if it's like, alright, like on number 5 it says write in scientific notation, but it's already in something.
10 moves the decimal when you multiply by a 10.
So each zero represents.
So I moved the decimal to right here, and it was right here. So the 10 moves the decimal. Each 10 that I multiply by moves the decimal.
So you just move it to an equal.
Yes. Yes.
Okay.
All right. So we'll do one more big number, and then we'll do a. Do you guys know how to write? Our national debt's probably like 34 trillion or something. I don't know what it is. Something like that. Does anybody know how to write 34 trillion? Okay, what comes after the trillions?
12 zeros. Or no, 11 zeros.
Trillions, and then what comes after the trillions?
Billions.
Billions. So, billions.
Millions.
Millions.
Thousands.
Thousands.
Hundreds.
Ones.
Oh. Yeah, ones.
Okay. Anyways, that's too long. I'm going to write it down here. 3.4, okay, and then times 10 to the, I'm going to count backwards. 3, 6, 9, 12,
13.
13.
This is the test I got to run.
Okay, but that part's not that bad, right? You can do that. Just can't count, right? Okay, sometimes you get really, really tiny numbers also that are really hard to write because they're so small. So also use scientific notation in this. So you put the decimal right after the first non-zero digit. So it's going to look kind of like this. So the first non-zero digit is 5, so it's 5.27 times 10. Okay, so is 5.27 bigger or smaller than the original number? It's a lot bigger. So to make up for it, I have to use, right, negative exponents. Does anybody know what multiplying by 10 to the negative 1 is the same thing as doing? It's like multiplying by 1/10, which is like dividing by 10 when you multiply by 10.
So couldn't you just use the division symbol?
you could say, well, yes, but that's not scientific notation. So scientific is always times. Just use a negative. So if you have a tiny decimal number, it's going to be negative something. That's the rule. If it's a giant number, it's positive. All right. So I put the decimal right here, so I just have to count 1, 2, 3, 4, 5, 6, 7, 8 places.
What did you say if there wasn't a 7?
So it wasn't a 7.
What if there wasn't a 7? Would it still be?
Oh yeah, that doesn't matter. It would just be 5.2 times 10 to the negative 8. So notice I wrote every digit after that wasn't a 0. So if this was like 0, 7, I would have had to write the 0 and the 7. Yeah.
What if the decimal was like in front of one of the zeros?
The decimal was in front of one of the zeros, like right here.
Yeah. Would you still count it?
You'd count from there to there. Yeah, they don't like putting the decimal at the very beginning. They like putting a 0 in the ones place. So I just don't usually do that. All right. That's not everything, but it's enough to get us going. So number 1, 390 million. I'm gonna start off with yeah, I'm recording. 390 million. Let's start with volunteers right off the get-go. Where did we stop yesterday?
We stopped at Jonas, so it's Skylar's turn.
Are you sure?
Yes,
No,
Skylar.
we were going back.
And plus we were going this way.
Then we stopped at Jaden going to Skylar's
Stopped
turn.
at-
All I know is that I did.
Yeah.
I've already done it, she's already done it, Lou's already done it.
Everyone's done.
Yeah, I think everybody did.
I have
I remember we started at Sophia, but I don't remember where we
Yes,
stopped.
now let's start on the other side.
I totally haven't done it.
Okay, Olivia.
Okay. 3.9 times 10 to the 7th.
Okay, not quite. So we got 1, 2, 3, 4, 5, 6,
8 times.
7, 8. Yeah, 8 moves. Okay, that was number 1. Oh, not number 2. Number 3, Sarah.
Oh.
So where do we put the decimal at?
5.2
Yes.
times 10 to the negative 5.
That was like my example from earlier.
Was it?
Well, for a second it was 5.2 times 10,
To the negative.
negative 5, is that right?
Yeah.
1, 2, 3, 4 zeros and a 5, yeah. That would be negative 5, yes. Number 5, Paxton. Okay,
Oh, we're changing it to the
no, this is not quite in scientific notation. This is one of the new things. What's wrong? Why is this not in scientific notation?
It's not after it's not between the 1 and the 3.
Okay, this is important. This is new. So I'm not gonna, Paxton, I'm not gonna give this one to you. So it needs to be right there. 1.36. Okay, now it's in scientific notation. Okay, here's the thing. Did I make this number smaller or bigger?
Bigger.
I made it smaller.
I meant smaller.
Okay, if I make this number smaller to make up for it,
You gotta make that one bigger.
I have to make this one bigger. So since it's one move smaller, it's like I divided by 10. To make up for it, I need to multiply by another 10. So it's 10 to the 8th.
That's not very nice.
Alright, so that's how you think about it. If you make the number smaller, the exponent needs to get bigger. If you make the number bigger, the exponent needs to be smaller.
Why can't it just be like 136? Or like
Well, whoever decided this is what scientific notation is going to look like
kind
said
of shows that.
chose the first digit as the ones place.
It always has to be a help us with numbers.
Yeah. Yes.
Or we haven't even started yet.
Number 6.
It's the same thing as 7.
6 is like number 5. The decimal is after the 7, so you have to move it 3 places to the left. which makes the number smaller, so your exponent has to get 3 times bigger. Three bigger.
So then it'd be like -5.
So here's another practice on number 7.
You did have it.
235.6.
Oh, shoot.
Okay. Also, it looks like scientific notation, but it's not.
Boy.
So I have to move the decimal to the 2.356.
Which would make it
Okay. Did my number get bigger or smaller?
smaller.
Smaller. By 2 moves.
Oh no.
So this needs to get bigger by 2. What's -4 plus 2?
-2.
Did I copy that right? Yeah, I did. Okay. Number 9. Okay, 9 says express in standard notation. What do you think standard notation means?
Just the normal number.
Change it to a normal number. Okay, so basically on this, if you're multiplying by 10 to the 8th, it's like multiplying by 10 8 times, the decimal is going to move. It's going to get, should this number get bigger or smaller?
Bigger.
Bigger. Multiplying by 8 10s, so the decimal is going to move 8 times to the right. So 1, 2 gets me past the 4. And then there's 6 more moves. So guess what's going to happen when I move the decimal 6 more times? Add 6 zeros. So 1, 2, 3, 4, 5, 6. And I'm going to go back and put in commas so I can actually read the number. Do commas backwards, right? Count 3, put a comma. Count 3, put a comma. You could kind of cheat on that one and do your calculator. I think it's easier just to count 8, but if it's too big for the calculator, I guess you can't cheat because the calculator would give you a scientific notation again. All right, number 11, 1.53 times 10 to the -4. Well, what's different on this one? What do you think is going to happen?
They're gonna be in front of the
3 zeros.
Right, it's kind of like multiplying by 1/10 4 times or dividing by 10 4 times. So the decimal is going to go backwards because it'll make the number smaller. So the first move puts the decimal in front of the 1. Then I have 3 more moves, so what's going to happen?
0.000153.
3 zeros between the decimal and the 1. Okay, did you say you didn't understand?
I kind of understand it, but it's still what she said.
Okay, I just moved the decimal back 4 places. 1,
Yeah, I understand.
2, 3, 4.
So
All right. Well, you can ask or ask me to check if you want to. 13. I'm not going to check all of them.
I'd like to
Okay, 13 is multiplying 2 scientific numbers together. The answer, though, has to be in scientific notation.
Would it be like
And I'm not going to, if you use your calculator on these, I'm not going to count it wrong, but you do have to have it in scientific notation. That's the problem. And there's probably a button on your calculator that can turn a number into scientific notation. But somehow you got to get the right answer. That's all I'm saying. So this is 2 times 10 squared times 3 times 10 to the 5th. Does order of multiplication matter? No. So in other words, since this is just a bunch of multiplies, I can just go ahead and do 2 times 3. Okay, and this goes back to like, what's 10 squared times 10 to the 5th? 10 to the 7th. You guys remember that? It's kind of like, this is why we're doing this right now. X squared times x to the 5th is x to the 7th, right? So this is 10 to the 7th. Is that in scientific notation?
No.
Yeah.
Okay.
It's 6. You could write 6.0 if you wanted to, but you don't need to. The book didn't even do that. 15. 3 times 10 to the 5th to the 4th. Okay, this one is different. Yeah, it's like 4 of those multiplied together. So it's like 3 times 3 times 3 times 3. 3 times 3 is 9, 3 times 3 is 9, 9 times 9. Okay. Yeah, do you guys remember how to do exponents here?
20.
Multiply, yes, times 10 to the 20th. Something is wrong with my
You
answer.
gotta move it over.
The decimal is in the wrong spot. It's right here.
My God, you're on high, bro.
So I gotta move it back. So it's 8.1 times 10. Did I make this 80, did I make 81 smaller or bigger?
Smaller.
Smaller. I turned 81 into 8.1. So to make up for it, I need to make this bigger. So it's 20. Number 17. 4 times 10 to the division. There's nothing any harder about division than multiplication. 8 times 10 to the 4th. Okay, this is more like, this is kind of like number 13, right? 13 was multiply, this one's divide. Any guesses what we're going to do first? Gianna?
You're gonna divide 8.
4 divided by 8. You guys know that off the top of your head?
0.5.
0.5. Since we're scientific notation, we don't really want the fraction here. So we'll do 0.5. What's 10 to the 11th divided by 10 to the 4th? 10 to the 7th. Alright, is it in scientific notation?
No.
No.
You gotta move the decimal over to the right.
The decimal should be right there after the first digit. So, did I make the 0.5 bigger or smaller?
Bigger.
I made it bigger. So I have to make this smaller. Okay, 19 through 22 are very different. What's different about those four?
Subtract.
Add and subtract. What are the rules with adding and subtracting in general? You can only add and subtract like terms. So we'll talk about it here in a second. I think 19 and 21 they made easy, and then 19 and 20 are easy, and 21, 22 are harder. Let's see, my plus 5.2 times 10 third. All right. Are these like terms?
Yes.
Yeah. They're like terms because these are both 10 to the third. So we have 4.3 of these plus 5.2 of these. So you can add these together. So 4.3 plus 5.2. Huh? 9.5, yes. I thought you said 3 point. Okay, anyway. All right, times 10 to the what?
The third times to the third.
Okay, pop quiz. What's this equal?
9x to the third.
9x to the third. So this didn't change. Okay, that would be x to the third times x to the third is x to the sixth, but we didn't multiply, did we? We have 4 of these plus 5 of these equals 9 of these, the same thing. So same thing up here, 4.3 of these plus 5.2 of these equals 9.5 of these, 10 to the third. So the exponent did not change. Is it in scientific notation?
Yes.
Yes. So we don't have to fix that one. Alright, the hard one. 2.8 times 10 to the 3 times 10 to the 7. What's wrong with 21?
They're not like terms.
They're not like terms. So, we need to make them like terms. I'm going to turn this one into 10 to the 9th. But if I do that, guess what?
You have to make the 3 different.
Okay, I made the exponent 2 bigger, so I'm gonna move
Make that one too smaller.
the decimal 2 smaller.
0, or no.
0.03. Okay, if you want to kind of give up on this one, you can plug it in your calculator and then change it to scientific notation. Okay, but what is, I don't know if you guys can do this without a calculator. What's 2.8 minus 0.03?
2.77.
Did you do that without a calculator?
2.8.
Not me.
Yeah.
You think I'm that smart?
Remember how this works? 2.8 is 2.80, 0.03. So it's kind of like $2.80 minus 3 cents.
Ah, so $2.77.
And then the exponent stays the same. Is this in scientific notation?
Yeah.
Yes.